Okay, so we're going to be going over rational exponents and radicals from our point 4. So this is our problem. It is number 53 in your textbook on page 50. Okay, so it says the directions to simplify each expression. Okay, so normally when we work with these kinds of problems with exponents and everything, we'll try to just simplify inside the parentheses first. But when I'm looking at this, none of the bases are the same. I can't really apply any rules of exponents inside the parentheses. This is an m, that's a base 2, that's a base n. And inside this parenthesis, we have a base n, a base 2, and a base m. So we can't do any of the inside simplifying. The next thing we can do is the power to power rule. Sorry if my paper moves around a bit. Okay, now that rule is, if you have a base to some power n, raised to the power m, we get a to the n times m. Okay? And then paired with this rule, we're going to use power to power. We're also going to use the other rule, a times b to the mth power is going to equal a to the m times b to the m. So in a sense, we distribute over multiplication. Okay? So let's do that. This is going to equal 2 raised to the 12th power times m to the 2/3 raised to the 12th power all over n to the 3/4 to the 12th power. Multiplied by, now let's work with this one using all of these, n to the 1/5 raised to the 10th power all over 2 to the 10th power times m to the 1/2 n to the 10th power. So all that we've done is, using these rules here, taken the 12 and multiplied, or distribute, you could call it, to each of the bases in the parentheses. Same thing here. The 10 to here, the 10 to here, and the 10 to here. Okay, so now, looking at all of these, we're going to try to do some simplification. If you notice, we have a lot of bases that look kind of like our power to power rule. We have an exponent on a base inside of parentheses being raised to another power. That's happening here, 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 and here. Okay, so let's do this rule. This is going to equal 2 to the 12th power. We don't need the parentheses anymore. And then m to the 2/3 to the 12th. Let's use this rule on the side. Let me pull out a different marker. Okay. So, working with this one, we have 2/3 times 12. Multiplying fractions, this cancels. We get 2 times 4, which is going to be 8. So, now we have m to the 8th power. All over. Now, n to the, using the power to power rule, let's multiply the exponents. 3/4 times 12. Same thing, bases, the 4 will cancel out with the 12. And we get 3 times 3, which is going to be 9. Good job. Okay. Now, we're done with this first part. Let's move on and do the same thing with the next side. N to the 1/5 to the 10th power. Using power to power, we'll multiply the exponents. Okay. Fractions, the 5 will cancel with the 10, and we'll get 2. So n to the 2nd power. And 2 to the 10th power, there's no power to power rule happening there. Now next we have this power to power. The m to the 1/2 times 10. Alrighty? Canceling bases once again. Sorry, if you can hear my dog howling, sorry. Okay. That's going to be 5. So m to the 5th power. Okay, now things don't look too bad. We don't have a bunch of parentheses everywhere and a bunch of half exponents or anything. So now, since this is all multiplication going on, I'm just going to multiply straight across and straight on the bottom. So we're going to get 2 to the 12th power, m to the 8th power, n squared all over n to the 9th power, 2 to the 10th power, and m to the 5th power. Okay, so now I'm trying to think in my mind what rules of exponents I can use. Now I see we have a fraction and a bunch of bases. Here we have a base m, base n, base 2, base 2. In my mind, I'm thinking of maybe using this rule, the quotient rule. A to the n over a to the m. What can I do? I'll keep the base and subtract the exponents. So now I'm going to just kind of rewrite this expression to look more like this rule. I'll pair the bases up from the top and the bottom. So 2 to the 12th, m to the 8th, n squared. So since this is all multiplication in the denominator, multiplication is commutative, so I can just flip things around with no problem. Okay, so now, if you'll notice, this is kind of set up like this rule. I have the 2 to the 12 and 2 to the 10, same bases. Got same bases and got same bases. So now I'm going to use this rule. Keep the base and subtract the exponents. 12 minus 10 will give me 2. Okay, same thing with the m's. Keep the base, subtract the exponents. 8 minus 5, that's going to give me 3. And once again, same thing with the n's. Okay, now this one's interesting. 2 minus 9 is going to give me, so you had $2 and you spent $9, you're going to be down $7. Alrighty, well, we're almost done. We've gotten things really simple. But I have one problem. I have that negative exponent hanging out. We're not allowed to leave exponents negative. So now I have to think of a rule that would help me get rid of that negative exponent. And I can think of fish out of water. So the reason that name has been given, thanks to Jalen, is that if you see a fish out of the water, it's a really negative experience for the fish. So how do we make a fish happy? Well, we put it under the water, and the fish is happy. So that's how we can get rid of negative exponents. Okay, so doing that, we get 2 squared times m to the 3rd power times, making the fish happy, 1 over n to the 7th. Okay, and we're almost done. We're just going to multiply straight across. And 2 squared, I think I can manage that. That's going to be 4. 4 times m to the 3rd power all over n to the 7th. And there we go.